I am Anil Kumar. In this video, with the help of these three questions, I am going to review basic concepts about periodic functions. Question number 1 is, determine axis, amplitude, time period, phase shift, and range of the function f of x equals to minus 2 sine 3x minus 60 degrees plus 1. Question number 2. Determine the coordinates of the new point after a rotation of 60 degrees about 0, 0 from the point 5, 0. Now this question is kind of tricky. What you need to do is like this. It's actually a simple question. We have a point 5, 0. That means we have a point somewhere here which is 5, 0. And this point is rotated by 60 degrees. So it comes to this. We need to find the new coordinates. That is it. Question number 3. Graph shows height of a pebble stuck on a tire of a bike. Find the speed of this bike in meters per second. Now this is a very important question. You need to find speed of the bike in meters per second. And part 2 is find time when the height of the pebble is 20 centimeters in first second, right? You can also do in first 3 seconds, right? So that is to say, at 20 meters, this is going to be the height, right? So I will do first second, but you could do find out all these points. Does it make sense to you? It's a very good question, and it will really help you to, so up to here, first 3 seconds. So in 3 seconds, you'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 1, 12 points. But we will do only in first second. Okay. So let's move on and see how to answer these questions, and I hope that will help you to understand the whole chapter. Question number 1. Determine axis, amplitude, time period, phase shift, and range of f of x equals to minus 2 sine 3x minus 60 degrees plus 1. Seems to be simple and straightforward. However, some of the students may do a mistake. Let me show you that. So what we should actually do is, before even attempting to answer this question, we have to factor this 3 out. So when you factor this, then you get x minus 20 degrees here. That is the phase shift. And this is the mistake which some students might do. Now it is straightforward, right? We need to find axis, so let's write down. Axis is 1. So you can write 1 here, or what 1? It is actually f of x equals to 1, right? That is axis. Sometimes we write y equals to 1. Since normally we say y is f of x, okay? Time period. So time period t can be found from this number 3 as in, if you're doing in degrees, since it is degrees, 360 divided by the k value, which is 3 here, gives you the time period. So it gives you 120 degrees. 120 we should write. So anyway, you can write 120. Now the third thing is phase shift. So phase shift, generally you will write the equation in the form, let me write down general form, right? F of x equals to a sine of k x minus d in some books plus c. So d is the phase shift, right? This is k, 360 divided by k. Now d is the phase shift. So let me say d, or the phase shift, is this value 20. You see that? If you do not factor, you will not get this correct answer. Now we're talking about range, right? So I missed amplitude, I think, in between. Amplitude A, which is this, is the number 2. Now we talk about range. What is range? For that, let me also sketch this function. since we are only taking 3 questions here, it's a good idea to, even sketch it. Okay. See, how do we sketch? +1 means the wave moves 1 unit up. So let's say I draw my axis here. So this is the axis of 1, right? Now what we do is we look for amplitude, which is 2. So from 1 it can go maximum that much up. So this line gives you that from here you have to add 2 to get maximum. Well, you could subtract 2 to go lower limit also. So we get our lower limit at -1. Does it make sense to you? So this is the axis at 1. This is maximum. We add 2, we get 3. And here we get -1. Now the wave actually starts negative, means goes downwards. So it starts after 20, right? It starts after 20, so there is a phase lag of 20. So it doesn't really start here. It starts after 20. So let's say that is 20. Okay, let's make it in 2 steps. So we will do the sketch. We'll do the sketch in 2 steps, which I normally do. So in step 1, I will only sketch -2 sine 3x plus 1. Is it okay? So let me sketch this first in light shade. So what I will do is I'll not take the phase shift, but rest of the things I'll take, and then I'll sketch this wave like this. Sine wave going downwards first, right? So that is what we mean when we are saying that's -2. Do you see that? And now when we say that it has moved 20 units to the right, and of course this time period here is how much? 120 degrees, right? So 120 degrees is the time period. So obviously the halfway through was 60 degrees and this thing came at 30 degrees. So 20 degrees, let's say this is x in degrees, 20 degrees is kind of that much, correct? So we are going to shift this wave to the right this much. Do you see that? By 20 degrees, right? So these are critical points. So we are going to shift these by 20 degrees. Do you see that? And what we get is our final answer, which is, kind of like this. So that becomes the wave, and it ends at 140 degrees. And it starts at 20 degrees. Do you understand that? So that becomes our final thing, right? So this is what I've drawn here now. Now from here, you can obviously see what the range is. So we wanted to answer the range factor. So range is the value of y or f of x. It goes from -1 to 3. So you could get range. Let me write down the formula for range here. Range is basically equals to the axis, which is our factor c. Let me call this as c, right? C is the axis. So it is c minus absolute value of amplitude, right? So range is y is greater than equal to and less than equals to c plus amplitude. Do you see that? So this becomes your formula for range. So you can add and subtract amplitude from axis. When you add, you get maximum limit. When you subtract, you get the minimum limit. So I hope this is absolutely clear, right? So now you have understood the basic equation. Don't forget to factor. That could be a mistake. So let me highlight this part. You need to factor 3 to get 20. Is it okay? Let's move on. And here is question number 2. Now many students do not really understand this question and therefore they are not able to do it. It's a very simple question. So what we have here is, the question is, determine the coordinates of the new point after a rotation of 60 degrees about origin 0, 0 from the point 50. So let's say this is our point 50. 50 means y value is 0, x value is 5. Now if I rotate this point by 60 degrees, basically I'm saying kind of like this, right? So we rotate, it comes to this point. So that is my rotation by 60 degrees. Is it okay? 60 degrees rotation. So we have this angle theta as 60 degrees and the radius still remain 5. These two things are equal, right? So this is 5. So we want to know what is the x and y value, the coordinates of new point. Do you understand? So let's call this new point as a point P. So this coordinate will be, if you see from here, x is r cos theta, that is, this is x, which is 5 cos theta. Is it okay? Which is 60 degrees in this case. And this is y, which is 5 sin theta, which is 60 degrees in this case, right? So the coordinates are x equals to 5 cos of 60 degrees and y equals to 5 sine of 60 degrees. Is that clear to you, right? Now to find 60 degrees, we could always use a special triangle, right? So this is the special triangle. It's a good reminder, right? The whole idea is to review as we move along. So most of you know all this, but there is no harm in repetition. Now 60 degrees means half, right? So it is 5 times half, or you can write 2.5 x value. For this, it is 5 times square root 3 over 2, right? So we could write the new point P as the x value is 2.5. Okay, let me write 5 over 2 since I want to write this also in the same fashion. 5 square root 3 over 2. Now that becomes the new point. So I hope the concept is clear. What happens when we rotate a point and get to a new point, right? So let's say the point was A, we rotate it to P. The last question here, question number 3 is, graph shows height of a pebble stuck in a tire of a bike. Find the speed of this bike in meters per second and find time when height of the pebble is 20 centimeters in first second, right? So 20 centimeters in first second. So we'll go up to here. So these are the points which we need to find. I'll really like you to pause the video at this stage, try it out, and then look into my solutions. Now to find speed, what should we do? Well, there are a few things which you should know, basics, and that is speed, distance, time relation, right? How are they related? Now distance is speed into time. So speed is distance over time, right? So what I have written here is speed is distance over time. That is speed. How do we find distance and how do we find time? So we are talking about a cycle tire. Okay, so the cycle tire means what? Imagine this, that this is your maximum, correct? And that is your minimum. It is running on the road. That is the axis of your tire, right? Now, so that means this is my tire. Is it okay? So what it does, it picks up a pebble from this point and it moves. Goes up, that is the point, comes down, and that is one full cycle. So that much is one full cycle. So this is 1 in our scale from 0 to 1. So that point is 0.5 seconds, since time is in seconds. Now height is in centimeters. Remember that part. So what really happens in 0.5 seconds? So we get our time as 0.5 seconds. And distance is 2 pi r, right? So the distance is circumference, 2 pi r. Now what is r? Well, from here you can see r is half of 60. So r is 30 centimeters. Do you get an idea? Is that clear? So again, what happens here is circumference is the distance d traveled in time 0.5 seconds, and circumference is 2 pi, the radius 30, in this case everything is in centimeters, and the time taken is 0.5 seconds. So now you get your velocity, right? Does it make sense to you? Right. So I've taken all the space in doing this. Okay. Now, so we'll write here that speed s is equal to 2 pi 30. That means 60 pi, and divided by time, which is 0.5, right? Which is when you multiply, you get 120 pi. 120 pi, but the units are centimeters per second, right? You need units as meters per second, so you have to divide this by 100. Okay, now let's find the exact answer. We'll also use pi as 3.14. So 120 times 3.14. So it is 376. So we could write now as speed as equals to 376.8, and I'm going to write it in meters per second. Only if I divide this by 100 I could do that, correct? So dividing by 100 gives me 3.768 meters per second. Does it make sense? Okay, so that becomes the speed in meters per second. Okay, so that is your speed. Now for part 2, which is find time when the height of the pebble is 20 centimeters in first second. So I need another page, so I'll do that. Let me write down A answer here. So A's speed will be 3.76 meters per second. So we'll continue in another sheet here. We'll just continue. We'll now find time when the height of the pebble is 20 centimeters in first second. So that is 20 centimeters, right? So if I draw a line, okay, then it intersects the graph at few points. Now these are set of solutions. So that is our limit. We are only looking for solutions in first second. So we have 4 solutions. How do we find them? Now that brings us back to even finding equation from the graph. So first part is to find the equation of the function, right? So we have to now first find equation from graph. Okay, so we look at few parameters to write down the equation, and the equation will be written here as h as a function of time, and we'll write this as a, and since it starts from the bottom, we'll say minus cos, right? We don't know what this is, but we'll write kt, and plus we don't know, right? So we'll write kt plus, we know how much up or the axis is. Let me draw the axis. So the center is right there, right? So that becomes the axis, so easily you could read this value as 30. So kind of like this. But let me show you how we got some values here. So first thing is, we just write down what is the maximum. So let's start here. So we have the maximum value, which is 60. Then we have minimum value, which is 0. Average value, which is this, which we call C, which is also called axis, right? Let me write x is C equals to, add them, divide by 2. So 60 plus 0 divided by 2, that gives us 30. So that's how we get 30. Now amplitude A is maximum minus minimum, that is 60 minus 0 divided by 2. So which is also 30 in our case. So now we know A is 30. So we will write minus 30 here, right? So h of t minus, because it starts from the minimum, not from the maximum, or you could write phase shift d as half of the time period. Now critical part here is t. How to find k? Now we found that one particular cycle is this much, so the time period is 0.5. Now so k is 360 degrees, divide by 0.5, and that is 720, correct? So we get 720. So that gives us the function height as minus 30. This 30 is amplitude. Cos k value of 720, and then we'll just write time t. All this is in degrees plus 30. Is that clear? Okay, so we have got this part. Now we want to find the time when the height is 20. So let's find out this time. So what we are saying is that height ht equals to 20. So we'll write 20 here for ht. Cos 720, and t is what we need to find, plus 30. Does it make sense to you? So that is how we'll actually solve this. Let's take this here. So we'll bring that term here. So we'll say now 30 cos of 720t is actually equals to 30 minus 20, which is 10. So we'll divide by 30. So we get cos of 720t is 10 divided by 30, which is 1 over 3. So we can say that 720t is equals to cos inverse of 1 over 3. We are working in degrees. So we'll find cos inverse of 1 divided by 3 bracket close equals 2. We get 70.528. So t is equal to 70.528 divided by 720. So let's divide this by 720. We get 0.0979. Okay. So I'm approximating this to 0.1. Is it okay? So 0.1 second is what I have approximated. That helps. That helps. The idea is to understand the concept. So we are saying this is 0.1. Now tell me what is the next point. Now, as you know, in cosine function, it is positive when? It is positive in quadrant 1 and also in quadrant 4. So these are the two values, correct? So the other value basically is that much. One full cycle minus the acute angle. Do you get an idea? Correct? So one full cycle minus, so there is a symmetry. There is a symmetry which we are looking for. So let me show you the symmetry here, then I'll write down the answer. Writing answer is not a problem. The symmetry is that these 2 points are same distance apart, right? Or you could also say that from 0.5 it is same distance apart. Is it okay? So we say T1 is 0.5, however T2 will be 0.5 minus 0.1. T1 is 0.1, T2 is 0.5 minus 0.1, so it is 0.4. Do you see that? So these 2 points are at 0.1 and 0.4, correct? Next 2 points will be, for next 2 points, we will add the time period, right? So T3 will be, we have to add the time period, 0.1 plus 5, and T4 will be 0.4 plus 5. I mean 0.5, correct? So that gives us 0.6 and 0.9. Do you get an idea? So we get these 2 points also by adding time period, right? So now we'll write down our answer that the time t will be equal to 0.1, 0.4, add 0.5, 0.6, add 0.5, 0.9 seconds when the height is 20. Do you get an idea? That is how we are going to answer this question. Now, as an additional question, I would like you to do it in first 3 seconds, right? So I like you to extend it up to here, find all these points also, right? So that will be a great exercise for you. You could take, instead of 20, you can say, when will the height be 50 centimeters? Is it okay? And find time in first 3 seconds. That could be a question for you to work on. I hope that really helps. Feel free to write your comments, share your views. This is also for a student who had a request on this. You may like and subscribe my videos, that'd be great. Thanks for watching and all the best.